Pythagorean Theorem. The Pythagorean theorem takes its name from the ancient Greek mathematician Pythagoras, who was perhaps the first to offer a proof of the theorem. But people had noticed a special relationship between the sides of a right triangle long before Pythagoras. This theorem, at least in a special form, was known to many great ancient civilizations all over the world, including Babylonia, Greece, China, and India, some of which predate Pythagoras and his school by 1,000 years. The Pythagorean theorem is one of the most popular to prove by mathematicians, and there are many proofs available. Incredibly, there are over 350 proofs of the Pythagorean theorem published today. The many proofs of this theorem come in all shapes and forms, spanning over many areas of mathematics and widely ranging in difficulty. The first proof we will discuss is one by Bhaskara, who is one of the most important Hindu mathematicians of the 2nd century. First, the area of the big square was found using the area formula for a square. Thus, the area is c squared. Then, Bhaskara found the area of each of the components, the area of the 4 blue triangles and the area of the yellow square. Putting those together, he got 4 times half times AB plus B minus A squared. Distributing the 4, you get 2AB, and foiling B minus A squared, you get B squared minus 2AB plus A squared. However, the 2ABs will cancel out, resulting in B squared plus A squared. Thus, the area of the entire component is C squared equals A squared plus B squared, which is the Pythagorean theorem. The 20th President of the United States, Garfield, also developed a proof for the Pythagorean theorem. He discovered his proof 5 years before he became president. He hit upon this proof in 1876 during a mathematics discussion with some of the members of Congress. The proof depends on calculating the area of a right trapezoid 2 different ways. The first way is by using the area formula of a trapezoid, and the second is by summing up the areas of the right triangles that can be constructed in the trapezoid. Now let's find the area of the trapezoid by summing the area of the 3 right triangles. The sum of the area of the triangles is the area of the yellow triangle, the area of the red triangle, and the area of the blue triangle. Since this area is equal to the area of the trapezoid, we have the following relation. Foiling out all of the lefts gives us the following, and simplifying this gives us a squared plus b squared equals c squared, thus concluding the proof. And last, we have a unique proof of the Pythagorean theorem proposed by Leonardo da Vinci, one of history's most interesting scientists. Leonardo's proof is as follows. Following the figure, he drew a triangle AKE and from each side constructed a square. From the hypotenuse square, he constructed a triangle equal to triangle AKE but flipped 180 degrees. And from the squares on the other sides of the triangle AKE, he constructed another triangle equal to AKE. Notice how a hexagon ABCDEK exists, and because AKE and HKG are mirror images of one another, about the line IF, I, K, and F are all collinear. To prove that quadrilaterals KABC and IAEF are congruent, thus having the same area, turn KABC 90 degrees counterclockwise about A. Also, the following pairs overlap: AK and AI, AB and AE, BC and EF, with all the angles between the lines still maintained. Thus, KABC overlaps IAEF, proving that they are equal in area. Da Vinci used the same method to show that the hexagons ABCDEK and AEFGHI are also equal. If one subtracts the congruent triangles from each hexagon, then ABDE equals AKHI plus KEFG. When simplified, this is C squared equals A squared plus B squared, the Pythagorean theorem. If any additional clarification is needed on any of the previously covered proofs of the Pythagorean theorem, please visit the following links.